All right, here we go. Part 2 on estimating a population mean, more estimating a population mean, and here we go. All right, to determine what we're doing today is two things. First thing we'll do is figure out how big the sample size needs to be a certain percent confident of our confidence level. So, determine the sample size n required to estimate the value of a population mean. We're going to use this formula down here. And again, it's the same formula we did yesterday, except we solved it for n. So sample size is z-score this time. Z-score, z-crit times the standard deviation over e. Now, e today is not a proportion, so it's actually going to be a number, which you'll see in a second. If the computed sample size is not a whole number, round it up to the next whole number, and then you're done. Let's try one right here. All right, assume that we want to estimate the mean IQ score for the population of stats students. IQ scores are typically designed so the mean is 100 and standard deviation is 15. So we know those two things. How many stats students must be randomly selected if we want a 95% confidence level that the sample mean is within 3 IQ points of the population mean? So I plugged this stuff in. N equals is 95%. We're using 1.96 so much now. So there's our 1.96 times standard deviation, which is 15. E on the bottom, we want to be within 3 IQ points. So 3 is our margin of error, or the 3, within 3 points right there. So just work it out. 1.96 times 15 over 3. Square it. Got 96.04. Which means I'm going to round that to 97, always the next whole number up. And that's all you do, just follow the formula. But the weird thing about that formula, I kind of misspoke there. We're using a z-crit, whereas yesterday we use a t-crit. And the reason why is because we know the standard deviation. So that's the difference, and we will use z-crit. So it's not exactly the same formula we did yesterday, but you can see what we're doing here in just a second. All right, this is the difference. Estimating a population mean when the population standard deviation is known. So when we know this. So I don't have a symbol for this on my keyboard, or I'll type it instead, but the population standard deviation is low sigma. It is rare to know the population standard deviation, or baby sigma, without knowing the population mean, but it can happen. And when it does, we're going to use a standard normal distribution instead of the t-distribution, which means we can use our z-crit instead of t-crits, and it also changes a little bit of what goes right here. But there's our formula for margin of error when we know that. When you know little sigma or population standard deviation. So a little bit different formula. So we got really 3 different formulas in this one section. Okay, let's try one here. On the previous video, yesterday's speeds were given from a highway in California. They're listed again below, same speeds. Use the sample speeds and construct a 95% confidence interval by assuming that the population standard deviation, or baby sigma, is known to be 4.1. So if you know it's 4.1, yesterday we did not know that. So I went ahead and found you still got to have X bar. So I punched them all in L1, did one var stats, got my X bar, and then the problem told me this. Told me that the population standard deviation was. So I'm using our formula, new formula, z-crit times population standard deviation over the square root of sample size. 95% means I'm using 1.96 for my z-crits. 4.1 is our standard deviation, and 12 is our sample size. Punched it in, I got 2.3198. So I'll take my X bar. The way you do your confidence interval is X bar plus or minus your error. So I just subtracted it and added it, and I found out my population mean would be between 58.4 and 63.0. All right, so same stuff we did yesterday, with the exception of we knew population standard deviation. Okay, quick summary here. This is the last 2 days combined. This is a great, if we were going to take a picture of a slide, this is it. This is really good. Choosing between T and Z normal distributions, when you're going to use which one. Okay, here we go. If you don't know baby sigma and it's normally distributed, or it's not known and is greater than 30, which those two always go together. So if you don't know baby sigma, you don't know this population standard deviation, use your t distribution. If you do know it and it's normally distributed, or you do know it and n is greater than 30, in reality, very rarely, we're going to use the z. So very rarely will we do that. Okay, if the population is not normally distributed and the sample size is less than 30, you can't do either one of these. You have to use something called a non-parametric mode, or method or the bootstrapping method, and we're not even going to do those. So we're more concerned about these two up here. When do you do which one? That's a great slide. All right. We'll work on this tomorrow like we always do. See you then.